Hello and welcome. Today we want to talk about small objects. As you know, Optris is providing a lot of infrared measurement devices, temperature measurement devices, and today we talk about our products for the high resolution applications, which means we want to measure, we want to detect very small objects. For that reason, we're going to talk about those three products. And before we start with the details of the products, let's have a look why this is important. The key market in here, of course, is the electronic market. Whenever it's about optimization of a circuit board, temperature plays an important role. As you can imagine, the cooling process is important, but also the single components plays an important role for such developments. The single components are defined by limitations in behalf of temperature. For that reason, the temperature of those devices is important to enlarge the lifetime of the whole device. There's a thumb rule according to Arrhenius, which says if you have a temperature difference of 10 Kelvin more, it will halve the lifetime of the device. And if we look into some examples for some such components, we see the data sheets in here are saying or informing about the temperature limitations. And for that reason, it's very important for the development of such boards to have an idea of the right temperature of each single component on the board. For that reason, Optris is providing those three different products. All of them are designed for microscope infrared temperature measurement, starting from the smallest and, let's say, easier device. It's the XI400. Then we have the PI640, as the name is saying it. It's a VGA resolution with a rather high magnification. And then we have our high-end product, also PI640, but coming with a much bigger optics to have a huge magnification, I would say, to measure objects down to 8 micrometers. A little more details on that. Let's start with the XI400 MO44. This device can create object or can make objects visible with a size of 80 microns. The resolution of the XI is 382 times 288 pixels. As you can see, the field of view is, in direct comparison, rather big. We are talking about approximately 3 centimeters times 2.3 centimeters. So for easy, quick applications, and also if you want to be more flexible in what you will see, or if you are interested more in the heat distribution on the board, this would be a very attractive product. In the middle, we have our PI640, as mentioned, the VGA camera coming with the MO44 optics. And this is designed to have a much higher resolution. In detail, we see the big improvement. Here we are talking about 28 microns, instantaneous field of view. Small explanation about instantaneous field of view. Here we're talking about the not the spot size, of the pixel size, which the camera is able to resolve. That means 1 pixel in this case equals to a square with a side length of 28 microns. And then we have our flagship, I would call it. This is the PI640 MO2X, means 2 times of magnification. It's not a 1-to-1 resolution, it's a 2 times magnification. And with this camera, we can have a much higher resolution, down to 8 micrometer instantaneous field of view. But on the opposite, as you can see, the distance, the operating distance is very close, so we have to go very close to the object, and also the field of view is limited. So here we're talking about 5.4 millimeters times 4 millimeters. And so in the end, it is a question of the application, what device is best suited. We have prepared a little experiment I would like to show you. I prepared such a, it's an infrared radiator. It's an heated device, a very small device. I can show it on the ceiling camera. So we are talking really about a very small, now it's sharp I think, a very small device. And now let's have a look to it with all of our 3 cameras. Starting with the XI400, we see there is a certain heat development visible. We see the object, we see more than the object because of the high field of view, of the large field of view. But the accuracy, the precision in behalf of the optical image is of course not that given if we compare it with our PI640, for instance. So here we go with our 640, we jump into our software, and you see if I activate it frequently, we see the heat development, we see the spot in the middle, it goes up and down, we have a clear information about the temperature, that's okay. But if we compare this with our next product, then we see actually what could be visible. And this is a huge jump in behalf of resolution and spot size. As you can see, now we are right in the area where the heat is generated. And here, as you can see, the heating area we can define by 2 times 2 millimeters approximately. And the 4.4 pixel size is as indicated. And we see now the true temperature behavior and even a distribution within this small, very tiny object. So that hopefully gives a rough idea about the difference of the product. Of course, when we want to have small objects measured or controlled by temperature, then the size matters. We want to go as small as possible. So that's why let's have a closer look to the 640 units. The camera actually is the same, as you can imagine. Also, by the way, the software behind is the same, free of charge. There's no difference. This is what they all have in common. But the optics is the key factor. So looking to this unit, you see we have a little microscope stand. You can adjust the size for a better focusing unit. So it's rather easy to use. And if we compare it, we have such features the specification here we can see. Let's again come with some optical words. The field of view in general is, in here, as mentioned, roughly 20 times 14 millimeters. The instantaneous field of view, the size of one little tiny pixel, is 28 microns. And then we have also another value called measurement field of view, MFOV. That means this is the recommended size if you want to have an accurate value of the object. So that means in this case we are talking about 3 times 3 pixels, and those 3 times 3 pixels equals to a square with a side length of 85 microns. This is the PI640 MO44. Now on the other side we see the PI640i with the MO2X optics. And here we see the big difference. The field of view is much smaller, 5.4 times 4 millimeters. And the instantaneous field of view, as mentioned, 8 microns, 1 pixel equals 1 micrometer. And the measurement field of view we see here, due to the characteristics of the optics, we need to have 4 times 4 pixels. But if we have the direct comparison, you see even by having 4 times 4 pixels, we are talking about still of 34 microns measurement field of view. In other words, if you want to make an accurate measurement, you can measure objects down to 34 micrometer in size. Yeah, that's the direct comparison. Let's have, to make it one more time clear what we are talking about, a more realistic or more real-life example. Here we see a dime coin in resolution. Yeah, we took this shot once with the MO44 and we see the whole coin, and with the MO2X we see we are much closer and we can see much more details. Yeah, that was it. Short but hopefully informative for you. Again, go to our website, have a look to our data sheets, have a look to our specifications to find out what device for microscope infrared temperature measurement is suitable for you.